300 billion. Just let that number sink in for a second. We're talking about 300 billion cubic meters of brand new global liquefied natural gas capacity set to just flood the market by the end of this decade. It's a completely unprecedented, massive scaling up of infrastructure, and it's going to permanently alter how the entire world generates power, fuels its industries, and honestly, just keeps the lights on. Welcome to the immense, mind-boggling scale of our global energy transition.
Hello, and welcome to this explainer. Today, we're going to do something really cool. We're going to connect these massive, macro-global shifts in energy straight down to micro, local execution. Because, we hear these staggering global statistics all the time, right? But what do they actually mean on the ground? How does a global trend turn into a local reality? Well, let's demystify the energy transition and see exactly how the future of our energy is being built.
Okay, let's dive into this. Here is our roadmap for today. First up, the global LNG wave. Then we'll look at shifting global gas demand, followed by the rise of low-emission gases. From there, we'll zoom way in on a real-world case study with Indonesia's Energy Balancing Act, and we'll wrap it all up with building an island network. Let's kick things right off with Section 1, the global LNG wave, and that massive 300 billion cubic meter expansion by 2030. The sheer scale of these global transport ships and export terminals, it brilliantly illustrates the industrial muscle driving this whole transition. This incoming wave of new supply, it's primarily being led by massive capacity expansions in the United States and Qatar. Together, those two make up about 70% of this new global capacity. The industry confidence here is absolutely rock solid. In fact, final investment decisions in U.S. LNG projects hit an all-time high in 2025 alone, with over 80 billion cubic meters per year of capacity approved. We're talking about projects like Louisiana LNG, Corpus Christi, and CP2 locking in literally billions in capital right now. What we're looking at is a global market that is actively, heavily banking on natural gas to provide both supply security and affordability for decades to come.
Moving on to Section 2. Shifting global gas demand and the big move from west to east.
Now, what's really interesting about this is the monumental geographic shift in where all this energy is actually going. It's a stark, undeniable contrast. Over in Europe, demand for natural gas is actively declining. It's expected to drop by 8% by 2030. Why? Well, a combination of historically high energy prices and a really rapid structural build-out of renewable energy has fundamentally reduced their reliance on gas. But then, look at the Asia-Pacific region. It is surging. This region alone is expected to drive 50% of total global consumption growth through the end of the decade. Places like China, along with emerging economies in South and Southeast Asia, are just incredibly hungry for energy to fuel their rapidly growing industrial sectors and expanding power grids. The global center of gravity for energy consumption is very decisively shifting eastward.
Which brings us to Section 3, the rise of low-emission gases and bridging that crucial emissions gap.
So as the industry expands, it has to simultaneously deploy technologies to clean up the value chain, specifically a technology called CCUS, or Carbon Capture, Utilization, and Storage. For anyone unfamiliar, this is essentially a technology designed to capture and store CO2 emissions directly from upstream gas operations and liquefaction facilities. The crucial point here is that by injecting that carbon safely back underground, producers can significantly shrink the greenhouse gas footprint of their LNG exports. And the best part? This isn't just some theoretical concept anymore. We are seeing serious momentum and deployment by major players, from the Gorgon project in Australia to Qatar's massive Ras Al Khaimah facility to rapidly developing projects in Indonesia and the US. CCUS is shifting from a demonstration concept straight into a mandatory feature of our future energy supply.
But what about creating greener gases entirely from scratch? If we look at the projected growth of low-emission gases, things like biomethane, low-emissions hydrogen, and e-methane, the trajectory toward 2030 looks fantastic. Biomethane production alone is expected to more than double in the coming years. That is huge progress for alternative fuels. However, we do have to look at this objectively. Even with this rapid expansion, these low-emission gases combined will still account for less than 1% of the total global gaseous fuel supply by the end of the decade. So they are vital seeds for the future for sure, but they aren't quite carrying the baseload of the global economy just yet.
So this brings us to a really fascinating question. We've spent the first half of this explainer looking at high-level global macroeconomic data. We're talking shifting continents, billion-dollar terminals, emerging green tech, but how does an actual, real-world, rapidly developing island nation execute this transition on the ground today?
To answer that, we arrive at Section 4, Indonesia's Energy Balancing Act, securing baseload and pioneering biomass.
We're going to use Indonesia and its state utility PLN EPI as our prime real-world case study to see exactly how they balance traditional energy security with green innovation. Check out this specific number, 181.3 million tons. That is Indonesia's 2024 domestic coal target, and it is legally capped at $70 a ton for the domestic market. Now, while the broader global conversation naturally focuses on moving away from coal, the on-the-ground reality for a developing nation is that affordable, hyper-reliable baseload power is the absolute foundation of their economy. You simply cannot build a green grid in the dark. By ensuring their power plants maintain over 20 days of operational stock on hand at all times, PLN EPI guarantees the baseline energy required to keep hospitals, schools, and factories running. Think of this reliable, capped-price coal as the sturdy bridge that allows the country to safely navigate into the energy transition without economic collapse.
And while they secure that baseline, they are aggressively building out the green infrastructure of tomorrow. PLN EPI has developed this brilliant four-agenda supply chain to integrate biomass right into their existing plants. First, they're planting energy crops on dry, marginal lands, programs like the Green Economy Villages in Gunung Kidul and Cilacap. Second, they're utilizing agricultural and forestry waste. Third, they are building out sub-hubs and main logistics hubs to process all this material. And fourth, they're using local cooperatives as mediators to ensure rural farmers benefit directly from the energy economy. Through this incredibly precise, localized logistics network, they're targeting 10.2 million tons of biomass co-firing. That specific, ground-level initiative alone will reduce CO2 emissions by 3.3 million tons every single year. It's a real game-changer.
Let's move to our final section and see how this all builds into the broader distribution picture. Section 5, Building an Island Network and the Concept of the Virtual Pipeline. Because Indonesia is this vast archipelago of thousands of islands, they can't exactly just lay down one massive continental pipeline like they do in Europe or North America, right? Instead, they're engineering a highly decentralized virtual pipeline. Look at the logistics here. They are planning 13 floating storage regasification units, or FSRUs, alongside nearly 50 onshore regasification units spread across 56 completely scattered locations. They manage all this through highly coordinated milk-and-run and hub-and-spoke models. Basically, this means specialized ships and ISO tanks are constantly moving back and forth across the ocean, distributing LNG from larger hubs down to tiny islands. It functionally acts exactly like a physical pipeline, but the whole thing is built entirely on water.
And what's the actual localized result of all this incredible effort? Well, they are successfully replacing 660 megawatts of highly polluting, expensive diesel power with cleaner-burning LNG in the Sulawesi and Maluku regions. We were talking about real, hard-won local victories in places like Pamala, Baobao, Kendari, Gorontalo, Ternate, and Ambon. Think back to the very beginning of our explainer. We started with that massive 300 billion cubic meter global number. But it is right here, in these specific island communities, phasing out dirty diesel for cleaner alternatives, that the true reality of the global energy transition is actually taking root.
It's like a giant puzzle, and mapping this journey from the macro all the way down to the micro leaves us with a really vital question to ponder. With millions of moving parts seamlessly operating every single day, from those colossal global LNG ships crossing oceans, down to the local village cooperatives harvesting biomass in Indonesia, do we, as a global community, have the sheer logistical willpower to completely transition our planetary energy systems without the lights ever going out? It's a massive challenge, for sure. But as we've seen today, the groundwork is already being laid. Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.